Okay, the other way we can measure our calibration factor, calculate it, is if we did a reaction in the container and our change in H for the reaction is how many kilojoules would be produced. So if we know how many kilojoules for a mole from change in H from a combustion reaction or from the energy in data booklet, or you're given the amount of kilojoules per mole from a reaction, then we can work out the amount of kilojoules for the certain number of moles that we would have used. So we're just using a ratio. So if we used half a mole and this is 1 mole, then you get half of whatever the energy for your reaction is. So we use that to work out our Q, our for the calibration factor, and so that's how many joules or kilojoules. And we measure the temperature again in the bomb calorimeter when that much energy is released. So we know how many joules for however many degrees it went up, and then we can calculate how many joules for 1 degree, which is our calibration factor. So if we do an example, so benzoic acid tends to be the classic thing that you use because it's got a known kilojoules per mole. So bomb calorimeter was calibrated to complete combustion of 1 gram of benzoic acid, and they've given you the molar mass. So we can clearly work out the number of moles of benzoic acid. So we've got that many moles, and we know that this much many kilojoules is released for 1 mole. So we use our ratio to work out how many kilojoules you would release for that many moles. So if you take that over the other side and cancel it out, then we get for that many moles you would release 26.35 kilojoules. So that was done in your bomb calorimeter and heated the water, and the water went from 17 degrees to 21 degrees. So our calibration factor is 26 kilojoules for this temperature rise, which when you divide that will be how many kilojoules for 1 degree. So that's our calibration factor. So this particular calorimeter, you would need 6.34 kilojoules for every 1 degree temperature rise. A bomb calorimeter was complete combustion with this temperature went from, so same idea, got a different number of mole. You know how many kilojoules for 1 mole of benzoic acid. So you've got 32.95 kilojoules for that temperature rise. So this particular calorimeter, you need 3.049 kilojoules for every 1 degree. So each calorimeter is different, so you need to work out the calibration factor for each calorimeter.